We're back here for example number 2, and the difference between example number 1 and number 2 is in example number 1, you were just being asked for the possible rational roots, and here they are asking you what are the roots. So we'll be solving this one all the way, but we'll be using that P over Q to get started. Also, I want to point out that we're dealing with an exponent of 3. In our next example, we're dealing with an exponent of 4. In our previous example, if we were to solve it all the way, we were looking for an exponent of 4. And I'm going to ask you to go back to the beginning of lesson 3.5 notes. I'll scroll there too, where we had the buddy system logo, these two little blue people, whatever you want to call them, where we had that complex conjugate that was always going to represent the pairs that had to travel together. So I want to remind you that when we're dealing with x to the third, we might have 3 rational roots, which means those p's over q's that we're creating, we might find 3 of those that work, and we wouldn't have any that were imaginary, non-real, or irrational. Or the other possibility is we might find just one of them that works, and therefore 2 more would come from a different place, not from that list that we are creating. So the p's over q's that we're working on are going to help with the top row where we're finding the real rationals. So in the example 3 that we're going to do, that example, it's got an exponent of 4. So all 4 of them might be real, only 2 of them might work, and it might be the situation that none of them work. So we'll be relying on this knowledge as we move to the next questions. So we'll go back to example 2 here. So we need to create our P over Q ratio. Our P value is going to be this 10. So 10 is P. And remember, we want the factors of 10. So stop and take a moment. Think about the numbers that multiply together to be 10. 1 will divide into 10. 2 will divide into 10. 5 will divide into 10. And don't forget 10. It divides into itself. Our Q value is the leading coefficient. It's not written there, but we should understand at this point that that number is a 1. And the nice thing when you're looking for your P's and Q's, if P and or Q, if either one of them are prime numbers, that really helps us not have as many choices. So we always like it when those numbers are prime. So the factors of 1 are simply 1. So our P to Q ratio that we'll write, remember we have to take those now and create all the possibilities. The only denominator that we have is going to be this 1. So our list of numbers will be plus or minus 1. That's from this numerator piece right here. And again, the denominator is 1. That's our Q. Or you can have plus or minus 2 over 1, or just 2. And we can have plus or minus 5 over 1, which is just 5. And we can have plus or minus 10 over 1, which is just 10. So this time we only have 8 possibilities. I say only 8. I know that sounds like a lot, but it's really not compared to what we could be working with. We have some pretty small numbers there. So the next phase of what we're going to do is trying to figure out which of those values might work. And to do that, we are going to test or check these possibilities using synthetic division. So this list of numbers that we've created right here, this list of numbers are possible roots, possible zeros, possible x-intercepts. possible solutions. And we're going to use synthetic division to see if any of them will work into our polynomial. Early on, it's really a matter of guessing and checking. I know that doesn't sound very appealing, but sometimes it is what it is. So I'm going to randomly select -1 to try first. So -1 will be what I use in my box. My coefficients are 1, -2, 5, and -10. As we're going along here, it's good to watch and follow along and pay attention, but it's also good to be thinking. Think about what you'll do next. Drop down the 1. What do you do after that? Well, we're going to take the 1 at the bottom, multiply by the -1. That's -1. Then we're going to add vertically. So don't just wait to write down what I have. See if you can be anticipating what will be there also. So as I'm going along here, I end up with a -18. Now, since this remainder portion right here is not what value would we want there if it's going to be a root of the problem? If you're thinking about that, hopefully you're thinking, hey, we would want that to be a 0. And it's not. So that tells us that the root -1 does not work. It is not a factor of this polynomial. It is not a root. It is not an x-intercept. It is not a solution. So we go back and we pick another one. I'm going to choose 2 this time. And you're welcome to test any values that you want until you find one that works. So again, we'll use 1, -2, 5, -10. And so walk yourself through that process. Aha! This time we do have a 0 at the end. That means that 2 does work as a factor. It is a root. So right now, we have x equals 2 as a root. Well, how many other roots are we looking for? I drew your attention to the exponent of 3 when we got started. So we're looking for 3 roots. We now have 1 real rational root. So I'm either going to have 2 more or I'm not going to have any more. And the other 2 are going to be non-real or irrational. Now, as I look at these numbers that were down at the bottom, the 1, 0, 5, 0, remember we started with x to the 3rd. So those numbers from the bottom now give us 1x squared plus 0x plus 5. And that's what we have remaining. Now, the nice thing about this is it's a quadratic. As soon as we get our exponent down to a power of 2, you can either try to factor it or use the quadratic formula. In this case, we could do the quadratic formula, but also without a linear term, we could just solve using square roots. So I'm going to go ahead and set that equal to 0. I have x squared equals -5. So now I'm trying to solve. I'm trying to get x by itself. Then we're going to take the square root of each side. So we have x equals plus or minus the square root of -5. Hopefully you recognize that negative under the radical. And that's going to now introduce plus or minus I square root of 5. And there are your 2 additional solutions. So we also have x equals I square roots of 5. And we have x equals -I square root of 5. And there are those companions, the 2 non-real solutions that must travel together for a total of 3 roots.